Okay. Today we'll discuss on zero copy cloning. That is one more excellent feature available in Snowflake. Okay. So what is zero copy cloning? What are the advantages of zero copy cloning, and how do we implement zero copy cloning in Snowflake? We'll see all those things, theory and practical both. So first thing, what is zero copy cloning? First, it can be any object same as the source object, derived from the source object and same as the source object is a clone, right? So like that, in Snowflake, it allows cloning. That means there are multiple database objects like tables, schemas, and databases. So in Snowflake, we can clone them. Okay, that means if I have a table and I want to maintain a similar kind of table with similar data, I can just clone it with another name. Okay, like that we can clone schemas and database. But here the advantage is, so even though we maintain multiple copies of same table, there will be no additional storage cost for the table. Okay, that's why we call it as a zero copy cloning. Even though we are maintaining multiple copies, there will be no cost associated, no storage cost associated with those clone tables. Okay, so whatever the main source table, only for the table the storage cost will be calculated. For all other cloning copies, there will be no charge. That's why we call it as zero copy cloning. So if you see in traditional databases, I have a table of 1,000,000 rows. Okay, and if I create a copy of the table with another million rows, what will happen? For those additional million rows also, the storage cost will be calculated, right? But here it's not like that. Even though you maintain 10 copies of the same table, 10 clones of the same table, there will be no additional cost. Okay, so that is the service offered by cloud services layer. It maintains the metadata, and we can create any number of clones with no additional cost. Okay, so what will happen if we clone a table? A snapshot of data present in the source object is taken when the clone is created, and it is made available to the cloned object. So whenever we clone one object, it can be a database or schema or table from another object. So a snapshot of that source object will be taken, and it is made available to the cloned object. So the same data will be available in the cloned object, but the thing is both are independent. So once you are done with the cloning, then there is no this one, how can I say, there is no interdependency between both the tables. Both are completely independent. Okay, the cloned object is writable, so you can write some data into cloned object, you can write some data into source object. So it's both are completely independent. Okay, changes made to either of the object, okay, it will not reflect in the other object. Only at the time of clone, whatever data present in the source object will go to the target object, the cloned object, but both are independent. Now you may get a question. Suppose I have some 1,000 rows in the table, and I have cloned that into another table copy. Okay, so what happens if I insert some 100 more records into my source table, source object? So what will happen? So it will not reflect into the cloned object. Cloned object still contains 1,000 rows. Okay, but there will be no additional cost for these 1,000 rows. Even though you are modifying your source object, there will be no additional cost. But if you modify any of these 1,000 rows in the source table, definitely only for that row there will be a cost. Suppose you have 1,000 rows in the source object, and the same 1,000 we cloned into another cloned object. Now I am deleting 100 records from these 1,000, okay, from the source object. In that case only, for those 100 records whatever deleted, for those 100 records there will be a cost associated with within the cloned table. Understanding, right? In the same way, you have some 1,000 rows in the source object, and you have cloned it into another cloned object. Okay, you are taking the copy of that into another cloned object, and so whenever we do that, 1,000 rows will come into that cloned object. And if I adding some 200 more rows into that cloned object, okay, what will happen? Only for those additional 200 rows, the storage cost will be calculated. Rest 1000, it will still point to the source object. Because this data is available in the source object, there will be no cost, extra cost associated for those 1000 rows. So this is how zero copy cloning works. So now you may get a question. So why we use no this zero copy cloning? Okay, so there are two popular use cases in the real time. Okay, so one is cloning the prod data into dev or test environment for our testing purpose. Okay, so whenever we want to do some unit testing or system testing, integration testing in the lower environments, we need some data for our testing, right? So we can bring some data from production environment to dev or SIT with no additional cost. Okay, suppose I have some 10 TB of data in production, but for my unit testing, I don't want all the data, 10 TB of data. I just need 1 TB of data in my dev environment. So I can simply clone those objects, okay, from prod to dev or prod to test, and I can use them for my unit testing. So here, without without additional cost, I am able to get some unit testing data and do my testing, right? So this is one biggest advantage. And second one is taking backup of the data. Suppose I have some daily load or weekly load or which is going. Okay, so daily some files are coming into S3 buckets. Okay, I'm loading the data into Snowflake tables. So the process continues. Suppose on on particular date every month we have a release, that means we are enhancing our code, that means we are doing some changes to our code. That code means, suppose copy command, we are doing some changes. So what happens on a day before our changes go to production. So suppose we are deploying our changes to production tomorrow. So what will happen if something goes wrong in the code? What will happen? Your data will be corrupted. Even the existing data may be corrupted, right? So in that case, just to make sure my historical data is correct and safe, I can take backup of the table. So that's we do in the traditional databases also. Whenever there is some major deployment, whenever we are doing so many code changes to our code, just to make sure at least the existing data will not corrupt, we just take a backup of the table. So here also in Snowflake we can take backup of any number of tables. Suppose my change is associated with the 10 tables. Okay, that means whenever I do some job change or code change, it may affect 10 tables, right? So what can I do? I can just take the backup of those 10 tables. So I can just clone those 10 tables into 10 cloned objects, 10 cloned tables. Even though we are taking 10 copies of 10 tables, what will happen? There will be no additional cost for those 10 tables. Okay, so Snowflake will maintain metadata for those 10 tables, and the data will be available in the cloned objects also. So this is about zero copy cloning and the popular use cases of zero copy cloning. Any doubts? So what is the syntax of clone? How you can write a cloning query? Okay, so it is very simple. Create or replace cloned object type. So it can be a database, schema, table, stage, file format, task, stream. Okay, you can clone any of them. So when you clone this stage or file format or task or stream, only the structure will be copied. Okay, there will be no data associated with that. Okay, so you can clone any of these objects. Okay, and cloned object name. So you have to put some name to your object name, and clone the source object name. Okay, so which object you are trying to clone, you have to give that object name. It's very simple. Create or replace a table name, clone, and the original table name. Okay, so we can clone all these type of objects. So if you see objects that can be cloned, so there are two types of objects, right? Data storage objects and data configuration objects. Okay, so the data storage objects are like databases, schemas, tables, and streams. Okay, so that's it. There is nothing more about uh, zero copy cloning. It's very simple, and let's do the same in practical. Okay, how we implement. Okay, let's go with cloning. So let's see. So first of all, how to clone a table. Suppose I have a table called customer, okay, in my database, okay, and I want to maintain a copy of the table into another table. Like I want to take backup of this customer table. So how to write our query? Create table, and so create or replace, we can write create or replace table. So my cloned object type is table, and I am trying to put one name for my cloned object. Okay, that is customer underscore clone. I am just giving. Okay, and I am cloning this object. Okay, my own DB public and customer table I am cloning. So let's run this. So clone created successfully. Okay, and let's check the data in both the tables. How many rows are there? Okay, if you see here, there are some 100 rows in the customer table. And if you see here, same 100 rows are present in the clone table also. Okay, so suppose if I want to create a just some part of the data, let's see how it will. Okay, create or replace this table where state equals to ACT. I'm just putting some filter. Not sure how it will work, but let's try. Okay, so we cannot do this. Okay, where is not working? So in general, in real time, people don't apply where, because even though you are cloning all data or some data, there will be no cost, right? So simply they write the clone object. They clone the complete object. Okay, so we cannot apply some where conditions. So if you want to clone, you have to clone the entire object. Understood? Are you good? So now, how to clone a schema or how to clone a database, we'll see. Suppose I have these schemas in my own DB, right? So I want to clone this schema, copy of file formats. File formats is my original schema name, and I want to maintain a copy of this with a copy of file formats. I'm creating one more schema by cloning the existing schema. Let's do create schema. Okay, so the schema was cloned. Okay, let's see. So here if you see, this is the file formats, the original schema name, and this is the copy of file formats, the cloned schema name. So if there are some 10 tables in this schema, all 10 tables will go to that schema as well. Okay, like that we can clone schema. So like that we can create clone databases also. It is simple. Create database, my own DB, copy. So I'm just giving this name, my the other database I'm going to clone. Okay, and clone, I'm cloning this my own DB. Simple command. As database is containing so many schemas and tables, it is taking some time. Okay, so just try to refresh. So here you see there is another this one, another database with underscore copy, because I have given the name as underscore copy. So if you see, all the schemas are present in that table, in that. And if you open any schema in the cloned one, you can see all these tables. Okay. And if you want to see the number of rows also, you can see in the customer table, you have 100 rows. Okay. That's how cloning works. Even though you are maintaining these many tables, okay, there will be no cost for these tables, entire this one. Okay, because it is a cloned object of the source object my own DB. Understanding? Now let's see. So I was discussing one point, right? So the source object and cloned object both are completely independent. So if you do some insert or update some data to the source object, what will happen? And if you update some data to cloned object, what will happen? We'll see. So we have to make sure like both are independent, right? So suppose if I'm changing some data in the source table, it should not affect in the in the clone table, and vice versa. Okay, so let's do that. Suppose for this customer, okay, I have data like this in the table. So for this customer ID, okay, the customer name is Lana Golden. Okay, I'm just trying to update this customer name as ABCDEFGH. Okay, so what I'm doing, just update uh, this table, set customer name equals to ABCDEFGH, where this customer ID equals to this one. Okay, so now I am modifying or I am updating the source table, right? So you can see here one row got updated. Now let's see for the same customer ID, what is the data present in both of the tables. Okay, so this is the customer table. And as I updated, the data looks like ABCDEFGH. Okay, and let's see what will happen in the customer clone table. So here it was not updated. That means once after cloning, both objects are completely independent. Okay, so whatever changes happening to one object, they will not reflect in the other object. Okay, like that we'll see. Now we will try to do some change over the cloned object. Okay, and let's see it will reflect in the other table or not. So I'm selecting the data for this. Okay, and for this for this customer, the state is now Western Australia. Okay, I am updating it to some XYZ. Okay, so let's see what is there in the clone table for that for that customer. So if you see here, the city is XYZ. So I did not update state, sorry, I updated city. Okay, and let's see what is the data present in the original source table. So it is Stirling only still. Okay, so you can make sure by executing these queries, you can make sure like so the changes happening to one object will not reflect in the other object, even though we are cloning. Okay, so I think nothing more to show here. So generally people execute only this statement. They just take the backup by using cloning. Okay, so there is another way of taking backup. Okay, create or replace table, suppose like this. So you should not do this mistake. Create or replace table. Okay, customer clone to as select star from this table. So here also a object will be created. Okay, so but what will happen, as you are not cloning, so whenever you apply clone keyword, then only it's a clone. Whenever you are creating a table like this, it's a table, not clone. Okay, so you, even though both are same, if customer clone 2 is containing the same data, customer clone is containing the same data, but we are not cloning here, but we are cloning, but we are creating another object. Okay, that's why. So if you do like this, if you do this mistake, what will happen, there will be storage cost associated with this customer clone to table. That's why. So in general, in the traditional databases, this is how we take the backup. Okay, before doing some code changes or whenever there is a need to take backup, this is how we take the backup. So this works in Snowflake also, but it will it will be costly. There will be cost associated with that type of taking backup. Okay, so you should not do this mistake. Okay, understood, right? Now, so suppose once you realize like I don't want any more the cloned objects and I don't need the backup. Okay, so you can simply drop those backups. Okay, so drop database, you can simply write a query like this: drop database and your database name, or drop schema, schema name, drop table, table name. Okay, so let's see. So even though they are not costly, but why we have to maintain multiple objects? That's why whenever you realize there is no need of those cloned objects, you can simply uh, drop them. So all the objects got dropped. Let's see here. So there is no additional database. There is no additional schema. You can see here in the left pane. Okay. So now this is very important. Okay. How to clone using time travel. Okay. Suppose I have a table. I'm loading some data into the table every day. Suppose yesterday some 1,000 records loaded into the table, and today some more records I'm loading, and I am updating some existing records into the table. Okay, so I did the update also, but I realized like I need the table. Okay, with the previous copy, yesterday's copy. So how can we do? But I don't want to maintain extra cost for the table cloned that for that copy. Suppose yesterday 1,000 rows were there. Today I inserted some data, 100 rows, and I modified some data. Okay, the existing data. I want to see that data and I want to store that data for my testing purpose, but I don't want to put more cost on the table. So in that case, what you can do? So you can apply time travel along with the clone. What will happen? So if you're doing some modifications to the table, okay, and if you want to fetch the original data without no cost, so you can apply both, like time travel and cloning. You can apply both at a time. Suppose if you see this query, how you can do that: create or replace table. Okay, my own this is the cloned object name I'm giving, customer time travel clone, and I'm cloning this object. Okay, so this is my original object, and I can simply put at offset or before timestamp or before query ID. So there are three ways of doing time travel, right? Getting the uh, uh, fetching the historical data. Here I'm doing this change. Okay, that means whatever the data present 5 minutes before in the table, I'm storing that data into another table. That is the table name is customer TT clone. Let's see how this works. Okay, suppose let's see what is the data in this table. I have some 100 rows in this table. Okay, now I'm deleting this 100 rows from this table. Let's see. So 100 rows deleted from the main table. I have deleted all the data from that customer table. And now let's try to query that table. So if you see, there are no records in the table. But as time travel enabled for this table, you can fetch this data still, right? So I don't want to load the data into the original table, customer table, but I want to make sure a copy is available with those 100 records. Now you can write a query like this: create or replace table, some cloned object name, clone, and this one. So what you can do? So you are getting some data here. So the table got created, and let's see. So this is you're querying this table. Okay. So you have the data, all the 100 rows. You are able to fetch and store here. Okay, so until what will happen now? So as there is no data present in the actual table, and until your time travel retention period is active, there will be no cost for this table. Okay, for this cloned object. Once the time travel period is over, then definitely this table, some storage cost associated with this table. Understanding, right? How you are merging the time travel concept with cloning. Okay, so until okay time travel retention period is available, okay, there will be no charge for this table as you are cloning it. But once that retention period is over, then the cost will associated. cost will be associated with this table, cloned table. Okay. So this is about the zero copy cloning.